All right, guys. This first practice, all right, it's 2, 2, 2, 3. We're going to talk about domain, range, increase, decrease, constant, what we did yesterday, and then we're going to graph a piecewise function together. On your test, I'll go over stuff that's going to be on your test. Your review is due Monday morning. I'm not doing the whole review. I'm not videoing the whole review. You guys will come in on Monday and say, hey, Mrs. Meadows, can you do this, please? I have a question on this. Okay, everybody understand? Yeah. Okay, so if I look at this first question, what are they asking me to do with g of -4, g of -2, g of 0, g of 2, g of 4? What do they tell me to do? They're saying, on the x-axis, go to -4. Tell me what the y value is. On the x-axis, go to 0. Tell me what the y value is. It's as simple as that, guys. So -4 on the x-axis, I go over here. What is my y value? +5. So your answer would be 5. I go to -3. No, I don't. -2. What is the y value at -2? +4. You guys agree? Okay, go over to -2, and then go up. Where does the graph cross? Now go to 0. Go to 0 on the x-axis. What's the y value? 0. Go over to 2. What's the x? X is 2. What's y? 3. And then go to 4. Your y value is 2. Does anybody have any questions about where we came up with those numbers?
So when it says g, it's always up.
No, that's just telling you function. They're saying function of. It could be g, could be h, could be f. But the number that they're talking that's in there is where on the x-axis do you look? Because you're looking for y. All right, so now, guys, if I talk about domain and range, first thing I want to talk about is domain and range. We'll talk about increase, decrease, all that stuff in a second. But for domain, remind yourself, domain is x values, right? X-axis. I know where you are. X values, and we read from left to right, correct? So what is the furthest left that the x values are used on this graph? -4. Does it include -4? How do you know that? Because it's a closed dot. Now I go to the right. How far right do I go? +4. Does it include 4? Yes, because it's a closed dot. Are there any breaks from the left to the right?
Yes.
No, there's no breaks in your domain. There's a break right here in your graph, but there's a value here. There's not one there, but there's a value. It's on the same x plane. So there's no breaks in your graph left to right. There will be breaks on your test. There will be breaks on an example we do here in a second. It's hard to see. You guys are going to have to really pay attention to what the graph is telling you. So now we talk about range. Okay, let's remind ourselves about range. Range is from low to high, right? And it's on what axis? The y-axis. It's our y values. So what is the absolute lowest that this graph goes? 0. Does it include 0?
Yes.
Sure does. And then what is the absolute highest that this graph goes?
5.
To 5. Does it include 5? Yes. Are there any breaks in the range? Are there breaks in the graph?
Yes.
Okay, so let's look at this. I agree there's breaks in the graph, but is there a break in the range itself? Here's how you tell. Do you guys see right here? There is a break right here, correct? So go across the whole graph. Is there a break? Is there a space where absolutely no part of our red graph exists? No. There's a break, I understand, between those two pieces, but there's other places on our graph where those values do exist. So your domain and your range don't have any breaks where you have a union. Yes, ma'am?
Didn't you?
All right, now we're going to talk about increase, decrease, and constant. I'm going to write it up here because I don't want to keep, zooming in and out. Increase, decrease, and constant. Now let's talk about this for a second. First of all, should any of these ever be left blank?
No.
No. If there's not an interval of increase or of decrease or of constant, we write the word none. But remember, you only look at the x-axis, and we only use what? Only use parentheses. You cannot increase and decrease at the exact same time. Are there any intervals here where your graph stays completely flat and horizontal?
No.
No. So what can I write right away for constant? None. Okay, good. Now, when we talk about intervals of increase, decrease, constant, remember we look at just the x-axis, and I told you cross off the y. Don't look at those numbers. I'm not concerned with intervals of increase, decrease, constant. We are not concerned with how high the graph goes or how low it goes. We're looking at from one spot to the next across the x-axis, left to right. What is the graph doing? So we always start on the furthest left, and I'm going to start right here at this point, and I'm going to follow my function till it makes a turning point. What was it doing the entire time in yellow? Decreasing. So from on the x-axis, it was decreasing from what number? -4 to what number? 0. To 0. Perfect. We always use parentheses. So now I follow my function because it made a turn, and it went which way? Up. Okay, so now it increased from where on the x-axis to where on the x-axis? From 0 to 0 to 2. Good.
Wait, why is it 2 and not 3?
3. No, mine's at 3.
3's over here.
No, but there's...
Oh, okay, yeah. Oh, I thought you were the Y.
No, we don't look at the y. We don't look at the y. We don't look at the y.
3, like 1, 2, 3.
We're not looking at the y. You only look at the x-axis. And now I say, okay, from here to here, what did my function do? It decreased. It decreased from where to where on the x-axis? From 2 to 4. So from 2 to 4. And there is our intervals of increase, decrease, constant. Now some of you say to me, well, how can I show work? Do you guys see how I wrote all over the graph? You can show me work. Not necessarily going to give you extra points or, partial credit or anything, but you can show me work. What you guys have to be so attentive to is if there should be a bracket versus a parenthesis. If something is included versus not included. All of those things mean a great deal. A bracket and a parenthesis are two totally different things. So if you don't have your notations correct, I am going to take points off. So make sure you guys are aware of that. All right, this graph is a little different. Let's talk about this graph. Tell me some things you notice about this graph. Kiara, tell me one thing.
There is a constant.
There is a constant. Good, very good. There's a constant. What else do you notice?
They're all separated.
Okay, they're separated. They're broken, as you guys want to say. That means there's going to be what? Multiple. We're going to have gaps, right? We're going to have unions. What else do you notice? There's an infinity. Very good. There's a lot going on in this graph. So let's take our time. Draw all over it. Remember, we use brackets and parentheses with domain and range, but we don't with increase, decrease, constant because we cannot increase and decrease simultaneously. So let's talk about domain. Remind me again, guys. I know this is hard. Let's focus. Where do we look? Good, Sam. The x-axis. So remind yourself, look, over here is negative infinity, and over here is what? Okay, good. So where does this graph begin? Negative infinity. I agree with you. We start over here at negative infinity. And it goes to what? To positive 5. Do you guys agree with that? I do not. Is it continuous from negative infinity to 5? No. It goes negative infinity to where? Negative 3. I agree. Negative 3. Why is it negative 3? Okay, guys, look, you have to pay attention to the gaps. First of all, does it include negative 3? No, but look right here. Look right here. If I draw, and again, I encourage you, bring color pencils. You can use mine. Look at my green that I just drew right here. Is there any part of the graph that exists where I have green? No. So how do you tell me, Mrs. Meadows, there is not a graph there. There's not a piece of the graph, so I have to put it together with something else. A union. We're going to bring it together. Good. Again, if you need to, guys, you are welcome to use my color pencils. I will sharpen them. So where does my domain pick up again? Right here at negative 2. Does it include negative 2?
Yes.
Good. So I put a bracket. Good. So we scoot on over. It goes to positive 1. Include or not? Good. Now, what do we notice? There's another union because there's a break. There's a gap. So where I have a union, where does my domain pick back up? Ooh, bad color choice. Hang on. Picks up at where? 3. Does it include 3 or no? Yes. And it goes to positive 5. Yes or no? Include? No. Okay, everybody look at that domain. There's a lot going on there. If you don't understand where a piece of it came from, if you have questions, I need you to ask me now. Ask me. The y-axis, good. From where? Low to high. So let's look. I'm going to zoom in here. What is the absolute lowest value on this graph? Negative 3. Does it include negative 3? Agreed. Okay, so negative 3 does not go all the way up to positive 3. It goes negative 3. If you need to color over it, look, there's values here. Hang on. There's values. Where's it stop? 0. At 0. Good. Does it include 0 or no?
Yes.
Okay, so let's talk about it. I heard, what? Okay, let's talk about it. All right, we have to, this is all one graph, right? So you guys see here where your values stop on this piece, correct? So you guys are thinking it stops there. But if I color along like I told you to, do values exist there? Yes, right? Your gaps are where values don't exist at all. So let's pick it back up. Hang on. Lots of erasing. So now I have a big old gap here. This is going to blow your all's mind. Let's see if anybody gets it. Big old gap. Now look, range is low to high, right? So what value does our range begin again? At 5. At positive 5, yes? Okay. Positive 5 to what?
It just stays at 5, doesn't it?
It just stays at 5.
You just write
How do you say it's just 5?
no parentheses.
Brackets?
Why is it a bracket?
Because only including.
Because it only includes 5. Fantastic. Garnell, did you have a question about this or what?
Yeah.
Okay, talk to
Why
me.
is negative 3 bracketed?
Because down here, what kind of a dot do you have at negative 3? It's closed, right? So it includes it. Good question. Guys, that's a hard concept because last period somebody's like, but it's an open dot. It's an open dot on this x value, right?
But it's going.
But it's a horizontal line, a constant value right there at positive 5. That's a tough question. You think you might see something like that? Possibly. Intervals of increase, decrease, and constant. What do we need to remember? Before we even start anything, what do we remember with increase, decrease, constant? X-axis. And what do we use only for notation? Parentheses. Okay, great. So, cross off your Y. I don't even want to look at it. Am I concerned with how high or how low my graph goes? No, I just want to know the interval over which something is happening. How much it goes up and down is not our interval of increase, decrease. It's from where to where on the x-axis we look left to right. So remember, over here is negative infinity, and over here is positive infinity, yes? So my interval of what? Where should I start? Okay, what's my constant? To negative infinity to where? Where does it stop being constant? Negative 3. Questions on that? Let's go to the next piece because we read a graph left to right. Let's look at it. From here to here. Say it again.
You go over the constant again.
Sure. Look at this is where we're flat, right? So it's starting over here at negative infinity, and it's constant till right there, whatever that value is. No, always parentheses. Good question. So guys, look, from this point to here, what are we doing? We're increasing from where to where? So negative 2 to negative 1, we're increasing.
I choose the 1.
Because
It's negative 1.
we're looking at the x-axis.
Only the x-axis. So now let's say from here to here, what did my graph do? It went down, it decreased. So from where to where? From negative 1 to positive 1. Good. And then I have a big old gap. There's nothing going on. And then I pick up again with something. What is my graph doing here to here? It's decreasing again from where on the x-axis? 3. X-axis, you're all right. X-axis, 3 to what? Guys, x-axis, 3 to what? 5. It's only the x-axis. You guys have got to remember that. Have to. Don't even look at up and down. We want left to right. All right, let's look at the piecewise. Now, some of you are sitting here like, oh my gosh, piecewise, I can't do this. Yes, you can. We all can do this. It can seem a little overwhelming because there's a lot going on. So just take it piece by piece. You have 3 different equations. Do you guys agree with me? F of x is a fancy way of saying what? So I have my first equation I'm going to do in blue. It's y equals negative x squared plus 7. You guys agree?
Yes.
My second equation is y equals negative 3 over 2 x minus 1, right? And then my third equation, I'm going to write down here. I'm just going to say, well, I'll write it over here. My third equation is y equals negative 7. You guys agree?
Yeah.
Okay, so let's look at this first one. Before I even start with tables of values and all this stuff, think about what this should look like. What shape is x squared? It's a U, it's a parabola. Is it a positive parabola or a negative one?
Negative.
How do you know it's negative?
The x is negative.
Because the x is negative, good. And so where does it move from the origin? It goes up 7. So your picture should look like this. Up 7, and it should come down like this. Yes. So watch. This is how you guys are going to figure out, well, I don't know where should you start? First of all, look where you're going to be looking. You want values that are what? Greater than 1. So I'm going to do a table of values, and I'm going to plug in negative 2, negative 1, 0, 1, 2. And I'm even going to go to 3. Because it takes 2 seconds to do, and I need a good picture of what my graph looks like. You have to be specific. Yes?
I didn't answer my own question. I was going to say, why are you plugging in the negatives, but that's for...
Just to see, yeah. So guys, think about this. When I plug in, I have negative 2 squared plus 7. What is negative 2 squared? 4. So you have negative 4 plus 7 is 3. So now I'm going to say negative 1 squared plus 7. What's negative 1 squared? 1. So then I have the negative out in front. So negative 1 plus 7 is 6. So now I'm going to plug in 0. What's negative 0 squared plus 7? 7. Now I'm going to plug in 1. I have negative 1 squared plus 7. I'm squaring 1, which is what? Then I make it negative. So negative 1 plus 7 is 6. I have negative 2 squared plus 7. You have to square 2 first. So it's 4, right? Make it negative. Negative 4 plus 7 is 3. And now I'm going to plug in 3. So I square 3, which is 9. Make it negative. So negative 9 plus 7 is negative 2. Now let's plot these points. So I had negative 2, what was it? Negative 2, 3. 1, 2, 3. Can you guys just tell me? So, thank you. Negative 1, 6, 0, 7, 1, 6, 2, 3, and then 3, negative 2, right? So now I'm gonna draw, and this is why your points are important. So look, I'm gonna do a dotted line. Why am I doing a dotted line, guys? Because I need to figure out what values I need and what values I need to erase. So now I have my shape. I know what my shape of my parabola looks like. Now I look and I say, okay, what were the boundary lines? What's that parameter that they gave me that I have to look for? Where x is what? X is greater than 1. So I'm going to go over here to 1, and I'm going to draw a vertical line. Where are all of the values on the x-axis greater than 1? To the right or to the left? To the right. So they're telling you that you want to keep all of this stuff over here We want to keep everything over here. And what do I do with all the stuff I don't want? I erase it. Perfect. So we're going to erase all of this. Now, you guys did a great job with that. There's one more thing we've got to make sure of. What kind of a dot do I have at 1? It's open. Make sure, hang on one second. Make sure I can see that it's open. Yes, sir. Let's go on to the second one. That was the hardest one we had to do. Wait, what? Okay. All right, so now let's look at the next one. What do we know the next shape of our graph is? It's going to be a line. How do you know it's going to be a line? It's x to the first power. So I can just tell you real quick that my slope is negative 3 over 2, and my y-intercept is that negative 1. Now, here's where you guys will make a mistake. Think about what a negative line looks like. Which way does a negative line slope? Downward. So your line should go like that when you plot your points. So I'm going to go to negative 1, and it's 3 over 2. So up 3, I'm going to go over 2 this way, down 3, and over 2 this way. You can do more points if you want to. You don't have to. Down 3 over 2, up 3 over 2. But you guys get a good picture of what your line looks like. So I'm going to do, yep. I plotted my y-intercept, which is at negative 1. And then your slope is 3 over 2. And it's negative, so I knew my line was going to be sloping downwards. So I just went up 3 over 2, up 3 over 2, put a point. So now I look and see what those boundary lines are that I have to look at. What are the boundaries that they gave me for this line? Between where and where? Between, don't even tell me what it has to be. What are the two numbers that I have to draw lines at? Negative 4 and 0. So negative 4 and 0. And x is in between those two. So what part of this, whatever color that is, what color, pinkish, what part of the line do I want? The stuff that's in between those two things. And then what do I do with the stuff that's not in between it? We're going to erase it. Good. Questions on why I'm erasing, where I'm erasing, that sort of a thing. And again, you guys are welcome to use my color pencils, just no pens because this is way too messy for pens. One more thing. Look, 1 second, Hannah. Now, what kind of dots do I have, guys, at negative 4 and at 0? Negative 4 is open, so make sure I know it's open. And at 0, it's what? Closed. Make sure I know it's closed. Do everything you need to do to let me know, like, hey, Mrs. Meadows, this is an open dot. Hey, Mrs. Meadows, this one is closed. Because if I have to guess, am I going to guess the right answer? No. Hannah, question. Let's graph our last one. And we save this one for the last because it's the easiest. If I have an equation that says y equals negative 7, what kind of a line is y equals negative 7? It's a straight line through y equals negative 7. So I have a straight line through y equals negative 7. Now I have to figure out what part of that line I need to keep and what part of that line I need to get rid of. So what is my boundary line for y equals negative 7? Negative what? Okay, so I'm going to draw a line right there. And it says y is less than or equal to negative 7. Where are the values on this line less than or equal to negative 7? To the left. So I want to keep everything over there and do what with everything else? Erase it. Good. And then the last thing is to tell me what kind of a dot do I have at negative 7? It's a closed dot. Say it again. Sure. And then we have a closed dot because it's or equal to. So do you guys see now this piecewise that you created? It's 3 pieces of 3 different graphs. What I'm going to be looking for is to make sure that you graphed your parabola correctly, that you graphed your line correctly. Maybe there's 2 lines, maybe there's 2 parabolas, whatever. But I'm also going to be looking if you should have closed dots or open dots, if you should have arrows on the end, or if it's just pieces of lines from one point to another. It's very important that you guys pay attention to all those little things. I'm going to take points off. Yes, ma'am. Because like here, it says less than or equal to. So it's telling you they want everything. Here, it's in between. You see how like X is in the middle? If x is in the middle, it's going to be a specific starting and stopping point. If x is on either the greater than or less than side, it's going to be one side or the other.